Question 6. I can see that this is describing a journey of a train, and I'm asked to draw a speed time graph. So I'll set that up first. Time always goes on the horizontal axis, and on this graph, this kind of graph, the gradient of the line is equal to the acceleration, and the area under the graph is equal to the distance travelled. Right, so the train moves on a straight horizontal track between two stations A and B. The train starts from rest at A, so velocity is 0, moves with constant acceleration of 1 meters per second, so that means the gradient of the line is 1, until it reaches a speed of v. So that is v, and that's the first time period. The train maintains this speed of v for the next t seconds. So that's the second time period, and that is t seconds, before slowing down with constant deceleration of 0.5 meters per second squared, coming to rest at b. So the gradient of this part is 0.5. The journey from A to B takes 180 seconds, and the distance between the stations is 4,800 meters. So I haven't used that bit yet. I've used everything else on the graph. B. Show that t is equal to 180 minus 3v. Well, 180 is the total journey time. So as all of these parts of the journey add up to 180, I'm going to make an equation with that. First of all, if I call this time period here t1, and this time period here t2, 3, and then I can work those out in terms of v. So the gradient of this line is 1, rise over run, v over t1 is equal to 1, so that means that t1 is equal to v. For this part of the line, minus v over t3 is equal to negative 0.5, which means that t3, if I rearrange that, v will equal a half t3, so t3 will equal 2 times v. So now I can just put those into the equation. So I have making an equation for the whole journey time. This part plus this part plus this part is equal to 180. So t1 equals v plus t plus t3 equals 2v equals 180, which means that t is equal to 180 minus 3v as required. Part C, find the value of v. Well, we haven't used the distance yet, and the distance is the area under the graph, which is a trapezium. So using the formula for the area of the trapezium, top, which is t, plus base, which is 180, so t plus 180 over 2 multiplied by the height, which is v, is equal to 4,800. So I'm going to multiply both sides of the equation by 2, making this 9,600, and also substitute, and getting rid of this, also substitute in for t 180 minus 3v. So 180 minus 3v plus 180 multiplied by v is equal to 9,600. Multiplying this out, 360 v minus 3v squared equals 9,600, and just rearranging, 3v squared minus 360 v plus 9,600 is equal to 0. Now you can do this in your calculator, or you can factorise and solve. If you're going to factorise, I'd divide through by 3 first. So v squared minus 120v is equal plus 3200 is equal to 0, and then you can factorise that to v minus 40, v minus 80. Now it's clearly not both, the velocity is clearly not both of those values, so sorry, I didn't write the actual values down. V equals 40, v equals 80. It's clearly not both of those values, so I'm looking for clues further back, and I noticed that I've got an equation here that says t is equal to 180 minus 3v. If I check my values with that, so if v is equal to 80, t will equal 180 minus 3 times 80. So 180 minus 240 is negative, so then t is less than 0. So you can't have the time here being less than 0. So we have to discard the 80 and give a reason. Marks wise for this, there are 2 marks for understanding marks, B marks, for the graph. One is for the shape of the graph, and that means that it has to start at the origin, end on the t-axis, and it has to be the correct shape. B2, the second mark, is for writing the values v, t and 180 that were given in the question. For part B, there's a method mark for showing how you've used the gradient to write these time periods here in terms of v. Now you don't have to have written t1 and t3 here, there are several ways of doing it. But as long as it's clear that you've used the gradient, you get that one method mark. An accuracy mark for writing the 2 v values into an equation made here, and then writing this here. So if you just write this, you don't get the accuracy mark because this was given to you in the question. You have to write this leading to this. It's all about the working on a show that question. So for part C, for one method mark for an attempt to use the area of a trapezium. It doesn't have to be the area of a trapezium, it could be the area of 2 triangles and a rectangle, but much easier to use a trapezium. There must be some dividing by 2 somewhere in the equation to get that mark. 2 accuracy marks, subtracting 1 mark for each error. So if you have more than 2 errors, you get no accuracy marks, but you still get the method mark. Forming the equation and getting to a point where you have an equation in V, a quadratic equation in V, equal to 0. So either of these, another accuracy mark, and then an accuracy mark for getting v equals 40 and v equals 80. Either one or both, or either 40 or both, and then one method mark for rejecting v equals 80 with a reason. So you must state that some reason. It doesn't have to be this, but as long as you found a reason why it can't be 80.